This video is going to look at relative maximum and relative minimum points. And what we're talking about there is if we have a graph and we're looking for a relative maximum point, then we're looking at where does your graph change from increasing to decreasing. And that point where it changes from increasing to decreasing is what we're going to call a relative maximum point. Okay, and then where your graph changes from decreasing to increasing, so here we're decreasing and then our graph starts to increase, that point where we change direction would be a relative minimum point. And that's all that we're looking at. So your graph may or may not have a relative max or relative min, and your graph could have multiple relative maximum and relative minimum points. But all that you're looking at is when your graph goes increasing and decreasing, that point where it changes direction, you would have a relative maximum, and then where your graph changes from decreasing to increasing, that point there would be your relative minimum. So if you think of this with probably your most common graph, your parabola, where we would normally think of your parabola here, we always call this point here the vertex. Well, that's also a relative minimum in this case because you're decreasing and then increasing. This would be a relative minimum point. And of course, if your parabola was opening down, you would have a relative maximum. So all we're looking at is where your graph is changing from increase to decrease or decrease to increasing. So if we have the following function, negative x squared plus 3x minus 2, we want to identify any relative minimum or relative maximum points. So to do so, probably the easiest thing is to look at using our graphing calculator. If we do so, we can go to y equals, and we can type in negative x squared plus 3x minus 2. And again, I'm going to start with zoom 6 or zoom standard. And we know that because we have this negative x squared, our graph is going to be a nice parabola here. In this case, it's negative, it's opening down. And another trick here we're looking at, we know that this point here is going to be our relative maximum point because it's increasing and then decreasing. Now I want to zoom in on this a little bit. So if I hit the zoom button and number 2 says zoom in, now we can move the cursor to the point we want to zoom in closer to. So I'm going to move the cursor over here to the right a little bit, close to where this relative max is, and then I'm going to hit enter, and it's going to zoom in right on that point. So we'll notice that the parabola goes up a little bit, so the relative maximum point is a little bit higher than the x-axis. So if we want to use the calculator to find the exact point here, now one way is, I'll point out, we can always hit the trace button. Now if you hit the trace button and we start moving the cursor, it'll trace along, and at the bottom you get the x and y coordinate. Now sometimes if you notice, it just jumps around, so you may not get the exact maximum point. So to do that, we're going to do like we did before. If we hit second function and trace, which would be the calculate, and we looked at calculating the 0, which is number 2, but now we have number 3 and 4 looks at your minimum and maximum. So for us, we look at our graph is opening here down, it's going to increase and decrease, so we have a maximum. So if we select number 4, it's going to go through the same questions we had before. You want to set a left bound, so we need to move the cursor to the left of this maximum point and hit enter. And then we need to move to the right of that point and hit enter. So once again, up here at the top, it's going to set your boundary, your left and right bound, and you're telling the calculator you want to find basically the highest point within this boundary. So then we're going to move the cursor, and this is one key point. You don't want to leave the cursor where it is for your right bound and hit enter. Sometimes if you do that, the calculator will say error because you're not picking a point in between the left and right bound. So make sure you're in between the left and right bound. And if you notice here, we get a maximum at 1.5 and 0.25. So there we have our maximum. And we know this would be a relative max where our graph is changing from increasing to decreasing. So there's your relative maximum point. You have 1.5 and 0.25. Okay, so that's pretty easy. All you have to do is locate that relative maximum point. All right, our next example. Now, if we notice we have a function here that is already factored for us. Now, we don't have to have it in factored form, and we could multiply this back out, but we can simply just leave it in factored form. We have x times x minus 2 times x plus 3. So once again, if we want to find any what we call relative extrema, so that's talking about your relative max or relative min, we can go to the calculator and type in our function. So I'm going to go to y equals, clear out the other function, and we're going to type in x parentheses x minus 2, close parentheses, open another set of parentheses for x plus 3, close parentheses. And again, I'm going to start with zoom 6, which is zoom standard. And here we have a nice graph that goes up, down, and then back up. And I think that's a pretty good picture of our graph. We could make this a little bit better maybe. If we wanted to zoom in a little bit, our x is going from negative 10 to positive 10. The y looks pretty good. If I adjust the x axis a little bit, we could maybe go into the window and maybe go from negative 5 to positive 5. And let's see if that looks a little bit better maybe. So that gives us a little bit better picture. And again, the main thing we're concerned about with this one is, again, identifying our relative max and relative min. So here we know up here at the top on the left we have a relative max because we're increasing and then decreasing. And then on the bottom right we have a relative minimum value because we're decreasing and increasing. So if we want to find this relative maximum point, once again, we're going to hit second function and trace. And we're looking for the maximum, so number 4. And over here at the left, we move the cursor to the left of our point. And once we get it to the left, we hit enter. Then we want to go to the right of our point, hit enter, and then go in between and make a guess, hit enter. And we end up with a maximum of negative 1.78 or negative 1.79 and 8.21. So there we would have, let's see, we'll just copy and paste this. So here we have our relative max. Okay, and then if we go back, we can look at finding our relative minimum. So this time we would go to second and trace, and we would select number 3 for minimum. And we have to go over again and set your left and right bound. So if we go down here, there's my left bound, move over to the right. There's our right bound. And then we want to guess. And notice here we get 1.11 or 1.12 and a negative 4.06. So here we end up with our relative minimum. So there's your answer. Now, keep in mind you could have more than just one of each. We could, if this graph went up, it could uh, go up here at some point and come back down, and you would have another relative maximum point. Now here, notice if we were to multiply this out, this is kind of looking ahead a little bit, but if we were to multiply this out, we would have what? X times x times x eventually, so we would have x cubed. So that tells us that the most number of turns we're going to have would be 3. So we go up, there's 1, 2, and 3. So whatever your exponent is, the largest exponent that you have, then the most relative max or relative min you could have is going to be 1 less. So if this is x cubed, then we know that the most max and min points we could have would be 3 minus 1, which is 2. And the same thing is true up here because we had x squared. The largest exponent is 2, so therefore if we subtract 1, that means you're only going to have one relative max or one relative minimum value. Okay, so it's pretty easy to identify. We're just looking at where does the graph change from increase to decrease or from decrease to increase, and we could simply plug this into the calculator to calculate your relative max and relative minimum points.